Welcome to this workshop for the hackathon, for the Resolve hackathon. I'm gonna give maybe a couple of minutes before we start so people can join. My name is David Barreto. I'm a developer advocate at the Starknet Foundation, and I'm here also with Sutong Chen. Let's see if we can see
Hello.
how many people we have right now. Okay, let's wait a little bit more. Okay. I'm not sharing my video right now. Sorry, I'm a little sick today, but hopefully you can see my screen, which is going to be the focus of today. Okay, we have one person.
We're also live on social media too.
Social media. Okay, so in that case, let's get started. So session today is mostly to show you about Cairo, the programming language that we use on Starknet. And one thing to keep in mind for Cairo is that you can use it obviously to build smart contracts on Starknet, but you can also use it to build just general purpose programming, programs of any type. Just the same way that you can use Python for writing any type of program, or you can use Python specifically for building like a REST API interface. So today I'm just going to focus on Cairo as this general language. So we build on this knowledge. So in the next workshop, I'll show you how to use Cairo to actually build smart contracts. So I'm going to have a Mac OS, but I'm going to jump on a VM so you can see how to install dependencies. And the project that we use to install all the dependencies for Cairo is called Starkup. So let me just zoom in. Starkup. And it is going to be this one here. So the link you see in the top, the GitHub repository, Startup. And this project comes with multiple things that we can use. Let me zoom in. So with this command, we are going to be able to install multiple binaries. The most important probably is called Scarp, which is a package manager for Cairo, where we define all the dependencies, where we do the compilation. And then it comes with more things that, for example, Foundry, which is like a testing framework for Cairo, based on Foundry that exists on Ethereum, similar ideas, but obviously everything is written on Cairo. It has also a DevNet, it has a Sierra compiler, it has more things. For now, we're really just gonna focus on Scarp because we're just gonna do basic Cairo. So basically you copy this command and it's gonna work for macOS, for Linux. If you're on Windows, you're gonna have to use WSL, like having a Ubuntu machine inside of Windows, and this will work. So put it in my terminal, and I just paste the command. Let me increase the font size a little bit. Proceed with direct installation. Let's click say yes. In the meantime, let me increase size. All right. Hopefully you can see it now. Okay, so it's installing all those dependencies. Let's wait until it finishes. And once it's done, you're gonna have to close the terminal and open again. So all these binaries are loaded into the path. So I close here and reopen my terminal. And again, zoom in a little bit more. One more. Now we can check that we have the binaries installed. For example, if you do scarp, which is the package manager, so by default installs globally version 2.11.4. It also starts SMForge, which is the binary for the Starknet Foundry for testing specifically. And then Starknet DevNet. So all the things that it was mentioned before, now you have it available globally in your system. But importantly, it also installed a package manager for any type of binary that is used normally in on Starknet. And that package manager is called ASDF. And that's going to be important because ASDF is going to allow us to define specific dependencies per project. So you can have one project that maybe uses an older version of Cairo for whatever reason, and then you have another project that has a newer version, and you can support both things, let's say simultaneously in the same machine without having to use Docker, so it's easier. So now that I have this installed, I'm gonna jump back on my Mac OS because I already did installation there, so I have the same tools, and then we actually start coding. So I'm gonna close here and go back to my sandbox. And just to show you, if I do Scarp version, I have a newer version. I'm going to show you how to install a newer version, but I have the binaries and also have ASDF. So basically, I install the same thing with Starkup on my macOS. So what I'm going to do at this point, I'm just going to create a new folder call it workshop. And I'm gonna get into it. And in here, the way you define to ASDF which version of the dependencies you want to use for a particular project is through a file that is called uh, dot tool slash hyphen versions, tool versions, right? So you create this file in the project, and now we can open. Let's open. I'm gonna use cursor, but you can use whatever, VS Code, for example. Put it here in the screen. Increase the font size. I'm not gonna be using any AI today just to focus on the teaching, so I'm gonna just disable autocomplete. If it shows up, it doesn't. Okay. So in this file, we're gonna find that I'm gonna be using maybe the latest version of Scar, which is 2.12.1. Okay. So once you define this, in order to actually use this version, you instruct ASDF, say ASDF install, and it's basically it's gonna make sure that you'll have this version defined here. So in this project, if I do scarp version, I should have 2.12.1 enabled for this particular project in this particular folder. Okay, so that's the dependency that I need, the only one. So next step, I'm gonna create a new Cairo project using Scarp. And for that, there's a command, the Scarp init. We need to give it a name to the package. Let's call this one workshop, same name as the folder. It could be a different name if you want to. And for the test runner, I'm gonna use, there's two different test runners for Cairo. You can use the one that comes with Cairo itself, it's called the Cairo test, or you can use Foundry. Foundry, you can use either one. I think Cairo test is a little bit more faster, more efficient, just because it's a smaller surface. So that's the one I'm gonna use for today. Test runner, it's gonna be Cairo test. So you can do it all in the command line, but even if you leave this out, just give it a name, it's gonna ask you, right? Which one do you want to use? Again, I use the default one just because today I'm focusing just on Cairo, not on smart contracts. So once I run the command, you can see that I have now some files created, right? The first file is scarp.toml. This is the configuration file of the project. And by the way, if you don't get any syntax highlighted here, just make sure that you have the right extensions. In my case, make sure to have this one, even better TOML. This extension is available for VS Code, for Cursor. It gives you syntax highlight for TOML files. And for Cairo, we also have this extension called Cairo 1.0 by Starkware. We're going to use that for autocomplete, sorry, for syntax highlight in our Cairo code. So make sure you have both installs. Let me go back here. All right, so what do we see here in this cargo.toml? Which, by the way, if you come from Rust, you might recognize this very similar to cargo.toml, which is a feature of Cairo. Cairo is similar in syntax to Rust, but it's a very different language under the hood once it gets compiled, because the whole idea of Cairo is that you can generate a proof out of the execution of a Cairo program. That's something that you cannot do with something like Rust. So first entry is going to be the package, and this is the name that we gave it to the command, the flag name workshop. Which version is it? You can keep modifying this as you keep working on the project. The edition is basically which prelude did you want to come like pre-bundle with your system. You can go to the Caro book, but basically you always use the latest edition available, and this is the latest one. So it has all the new things in the language available for you without having to manually import all those things in your code. And then this is the section where you define dependencies for your project, either dependencies at runtime or dependencies just for development. And the one that we have right now for development is only the test runner, the Cairo test. And this one is actually matching the same SCAR version that we have, 2.12.1. We have a source folder which comes with one module, lib.cairo, and this is always the entry point of any Cairo project. It has to be a lib.cairo. And here we have some code that comes predefined with the code. So we have some function calling another function, and then we have some unit test. I'm gonna delete this because I want to do coding from scratch. So let me explain things step by step. So I'm gonna delete this for the moment. And I want to break down every topic in different modules just to make it easier to read. And so I'm gonna start first talking about, give me 1 second, just checking my notes on the other screen. Okay. I'm going to create a new file here in the same source folder. I'm going to call it functions.cairo. Okay. Now, this is going to be a module in my system or in my project. So to make it a module, I have to basically define it here. So lib.cairo is always the entry point. So I do mod function, so the same name of the file. So now I'm saying, okay, in my project, there's a new module that is actually available in a file called functions.cairo. So here, so this is now the connection with the project. So let's talk about simple functions, right? So define a function, you have to use the keyword fn, and then you give it a name. Let me disable autocomplete. It's a little easier for teaching. All right. You give it a name. Let's call this one foo. And you always have to define, I mean, if the function returns a value, you have to define the type that is being returned. Let's say this one returns an unsigned integer of 32 bits. And it complains because say, okay, if you're going to return this, what is the value you're returning? So to return a value, let's say 5, if you omit any semicolon, you're saying, okay, just return this value as the function is executed. So now this is complying with the type. Let's say that we have another function, let's call this one bar. It also returns u32. But now bar is able, if you want to call another function very easily, just similar to any other language, basically you define the invocation, it will call this one. And the idea is that bar calls foo and then returns whatever foo returns. So I'm gonna omit the semicolon, so that's gonna return 5 as well, right? If I put the semicolon, notice that it's gonna complain because this now doesn't return anything, so we're not following the signature of the function. So let's go back. And let's create another more interesting function. Let's call this one double. And this one now expects an argument. And the argument is called x. You always have to define the type of the argument. Let's say that it's also u32. And basically whatever you pass is gonna double it. So it's gonna return another u32. And basically a simple operation will be doing this, right? Whatever you pass, duplicate, and that's it. So no semicolon, it returns the value. So let's check that these functions are working. This is the way I like to prove that it's working without having to print to the console. So when you want to create like a unit test, you have to wrap a module or identify this module with an attribute. It's called CFG, and then test, singular. This basically saying that whatever module I define underneath, it's called test, this module is only going to get executed when I run the test. If I want to execute the program, it's going to ignore the compilation and the execution of this section. That's all it's doing. So to bring these functions into scope, because now I have a new module, so this module doesn't have visibility on these functions, you can use super, so it goes one level up, and now you can define individually, like, okay, bring bar, bring foo, bring double. So now I can use it in my test. You can do it this way, or the easiest one, maybe I'm gonna comment this out. You simply use an asterisk and say, okay, bring everything that you can see above you, like in the module above you, okay? All right, so let's create the first test scenario, basically just to test that these functions are working. And to define a function as a test scenario, you use the attribute test. And then I find, okay, this function, let's test the first function, foo, okay? So to test that something is working, you basically do an assert. These are all macros. Basically, I want to verify that if I call foo, what I get back is 5, right? Because that's what foo is supposed to be returning. Okay, so this is my first test scenario within my test suite or my unit test for this module. And let me remove this code here for easier visibility. So now let's run this. So to run the test scenario or the test suite, you do a scarp test. And there you have it. So it found the test scenario, test foo, inside the test module, and it passed. Okay, one passed. So that's good. That one's working. So now you know how to create some simple unit tests. So let's actually test the other functions, right? So let's create different test scenarios. Test. In this case, let's test now bar. In the case of bar, the assertion will be, what are we trying to find? That if I call bar, I get 5 as well. So let's see, if I call bar, I should get 5. Let's verify. Yes. So 2 tests passed. Good. It's important to see test fails as well. Like, what if I put just a wrong number, 8, just to make sure that the tests are actually working and not just getting like a false positive. And sure enough, the test is failing because this is supposed to return 5. If you want to return a more descriptive error message, you can actually put the error message here. Uh, the function bar should return 5, right? So now when this function, this test fails, it will test with that specific error message, just to help you out to debug where to actually fix the test. Okay, let's bring it back to the actual number 5, run the test, and it should now be passing. Okay, good. And the final test will be to test double. So function test double. And now we do again an assertion with exclamation, and then we can function double, and we can pass some value. Say if we pass the value of, if we pass 5, we should get back 10, right? That's the double of 5. If you run it, and it's passing. Now 3 tests are passed. Right, so now you know how to create functions, how do you find the signature for the return type, for arguments, and basically how to do simple unit tests with Cairo test. Okay, let's go to a different topic. Let's talk now about mutability. So let's create a new file inside source called mutable.cairo. And to bring this module into my project, I need to define it here. So same name as the file, mutable. Okay, great. So now it's part of the project. And what I want to do here, let me check my notes, mutable. Okay, I'm actually going to start directly with some test scenarios. So to create a test suite, I use the attribute CFG test. So to create a test suite for the module. So, okay, so first scenario they want to test is going to be function test immutability. Okay, because if you're coming from Rust, you're going to see something familiar here. Every variable on Cairo is actually immutable by default. And this is what I mean. You can create a new variable with the keyword let, just give it a name. You can give it a type. For example, let's say this one is U32, and you can give it a value. Let's say it's 1. Okay, this is your variable defined as A. Now, let's say that I want to change A to a different value. So let's say A equals 5. That is not allowed, right? Because by default, every variable in Cairo is immutable, meaning that once you define a value, you cannot just simply change the value of it. Okay, so what you can do, let me just comment this out because this is not going to compile, obviously. You can do what's called shadowing. Okay, this is one way to do it. So let's say function test shadowing. And what shadowing do is that let's start with the same variable. I can actually redefine the value again with a different value. I mean, redefine the variable with a different value. And this is allowed, right? Because this is not technically mutating the value. It's simply creating a new variable. It just happens to have the same name. And because they have the same name, now this variable definition is shadowing this one. And to prove that, if I do an assertion, like give me the value of A, it should be 5 and not 1. Okay, let's give it a try. And there you go. It is passing. There is, of course, a warning. It says unused variable. Consider ignoring by prefixing with an underscore. So what it's saying is that it's recognizing that these are 2 variables, but only one is being used, the second one that is shadowing the first one. So just to mention that, hey, I know I'm not using this, it's on purpose. You just prefix with an underscore just to get the warning to be gone. If I run this again, it should pass, but with no warning now this time. It's just a trick, it's just a convention, but the compiler understands now that it should not warn you. Now, you can actually make variables mutable. Now, you have to be explicit about it. So let's see how it is done. Function test mutability. So now let's say that we have the same variable A. I'm gonna copy this here. I'm gonna remove the underscore because I'm actually gonna use this variable. So how do I tell the compiler that I actually want to make this variable mutable? Easy. You can just find the keyword mute at the before you define the variable, right? So now you can actually go ahead and say a equals 5. And now this is allowed, right? Because now you explicitly told the compiler this variable a is going to be mutable. And to prove that, again, we can do an assertion, say a at this point should be 5, right? Run the test, and it's good. 5 tests passed. Great. Um, Finally, I'm going to show you how to create a constant because I show you how to create variables and they're immutable by default, but you can make it mutable. And to create a constant, function test constant, what you do is the keyword a const. Convention is to use uppercase for constants. You always have to give it a type and then assign the value. Okay. Very similar to a variable. Obviously, you can never make a constant mutable. That is not allowed. And so you can never change once it's defined. Okay. So easy, you can do an assertion. A should be equals to 1. Test it. And just to show you, if I try to modify this, obviously it's not allowed. And the keyword mutable is also not compatible with a constant, just so you know. That's the difference. Okay, summarize. Variables are immutable by default. You can actually do shadowing, so create a new variable with the same name, with defines or is it defines the value over whatever you defined before. Or you can make it mutable by using the keyword mute, so now you can make changes. And finally, you can get create a constant with the keyword const. Cool. Topic number 3 is integers. All right, let's get a new file, integers.cairo. And because it's a new module, I have to define this module in my project here in lib.cairo. So integers, all good. Okay, let's see what I have here defined. Integers. Okay, I'm gonna start by creating my test. Define a module as a test, a unit test. So again, CFG test, name my module. Let's have some test scenarios here. First thing I want to show you is some basic math with unsigned integers. We use some unsigned integers in before U32, but there's many of them. So if I go, the scenario is test function basic, test basic uint math. And let's say that we have two variables. Let's say I have a, and this is 3, and then we have b, and this is 5. Important that if you don't define the type explicitly, the compiler is going to think that is not an integer, that is something else, which is called felt 252. We're going to talk about that later. So to make sure that it's actually an unsigned integer, we have to always define the type with a colon. So let's say this is U8, unsigned integer of 8 bits. It's a very small variable, both of them. So let's do some simple math with unsigned integers. So you can do addition, a plus b. Obviously, this is equals to 8. We can do subtraction. For example, b minus a, this should be equal to 2. We can do some multiplication, a times b equals to 15. We can do division or integer division, right? So b divided by a, that's going to be equals to 1. That's because this is the integer part of the division. It's important, right? This is not a regular floating point division. There's no floating point in Cairo, the same way there is no floating point in Solidity. And finally, you can do modulo, like a base mod a, which is the reminder of the operation of division. This goes is going to be 2. So we can run the test, and they all passed. I use U8, but you can use U16 or U32. or U64 or U128 or U256, right? Those types are all supported, or also U size. That is essentially the same as U32. Just using UA because it's small numbers, so it doesn't matter. Great. One benefit of using integers is that you get some overflow protection, and this is very important for smart contracts. And let me show you that. Function, let's call test uint overflow protection. And in this case, what I want to do is that if we define a to be an unsigned integer of 8 bits, in 8 bits, the maximum value you can store is actually 255. That's the maximum value because it goes from 0 to 255. Now, the point is that if I try to increase it by 1, which I'm trying to do here, I want to show you is that this should fail. And probably, what am I doing here? Plus B. Oh, yeah. This should fail. So to create a test that is actually verifying that is failing, in this case called panicking, right? You have a new attribute that's called should panic. So basically this is testing that there's overflow protection is in place and it's preventing from the value to go over back to 0 or whatever different number. So it is passing because this code is panicking because 256 is not allowed in a type so small as U8. This is going to be relevant when we talk about fails because fails, the way they work, they don't have this overflow protection. And in the same way that it has overflow protection, it also has underflow protection. Let me show you. Test function test uint underflow protection. And we can do something similar, maybe again, a small types. You can actually use sign integers as well. So, but I'm gonna do it later. For now, U8, let's say this is just 0. So obviously, if you try to subtract 1, it will try to go to negative, to -1, which is not allowed for an unsigned integer. So let's give it a try. Let's say that B is 1. Okay, so now let's try doing A minus B, which in theory should try to go to -1, but being an unsigned integer, this should panic. And if we run the test, of course, it is panicking, right? Because this is the underflow protection activated. So we can use the same attribute should panic, saying, okay, if this function panics, the underflow protection is working correctly, so the test should pass. So now it's passing. Now let me show you, I mentioned that the same way that you have unsigned integers, you also have signed integers. So you can actually handle negative values if you want to. So let's create a new test scenario. Let's call this one test basic int math. So let's start with some basic math like addition, multiplication. So again, let's create a variable a. Now let's say that is a signed integer 8, right? So 3. Now let's say that b is I8 equals 5. And essentially you can do similar math as before. So I can just copy paste the same instructions here. Maybe you can do some small modifications so you can see the value getting negative. For example, if I do a minus b, it should be -2. And this should be allowed. So let's give it a try, run the test, and everything is passing, right? So you can see with sign integer now you can go negative. It's just the difference that now the maximum number positive that you can go with sign integer is like half what you can do with an unsigned integer. And you have the same abilities to overflow protection. I'm gonna show you here. Test. Let's call this one, oops. Function test int overflow protection. And in this case, the variable sign integer of 8 bits. Now the maximum value you can store is 127 with a sign integer. So if you try to go 1 over, it should fail. So a plus b should panic, right? So same, if it should panic, we can use this attribute should panic. So let's give it a try just to verify that we have the same overflow protection and it is passing. So that's good. It's protecting for overflow. And the same for underflow. Function test int underflow protection. And this is going to be, let's say that we have the minimum value you can have with the sign in. It's going to be minus 128. And then if you want to try to go one value lower, for example, you can do a minus b. If you try to go to minus 129, this should fail. Okay, if we have overflow protection, so should panic, run it here, it's passing, right? So it's saying, okay, you cannot go below 128 because that's the minimum you can store in I8. Of course, you can use bigger types, use 16, I32, I64, I28. There's no I256, just so you know. And there's no I size that doesn't exist for signed integers, only for unsigned integers. And okay, so I show you how to do some basic math, right? Like multiplication, addition. But what if you want to do something more complex, like try to raise to the power of 2 or to try to find the square root? So this is where I show you how to actually bring dependencies to the project. And to find what dependency you can use on a project, you can go to scarps.xyz. Let me show you my browser, 1 second. So if I go to scarps.xyz, this is the registry of all the dependencies of, is it plural, scarps? Yeah, what is the, it's not the scarp. I was doing something wrong with the name. Okay. So this is the registry for all the Cairo packages. The one that I want to show you is called Alexandria for more advanced mathematics. And you can do multiple things with Alexandria, more complex operations. I want to use just a simple one, Alexandria Math. So I want to bring this into my project. And to do that, I need to go check in my notes. Right. So you have to go to your scar.toml. And now you can use the dependency section. Say, okay, I want to use a new dependency. And the name will be this one, Alexandria Math. You can use the same command scarp add, for example, or you can directly put it in the scarp.toml. I'm going to use it directly. So I'm going to do Alexandria underscore math. And I want to bring the version, the latest one, which is 0.6.1. 0.6.1. So now it's one dependency. So in order to use it in my project, I go to integers. So I have to bring them to scope, the functions that I want to use. So I'm gonna go to the top of the module here. So let me bring Alexandria into scope. So I use the package name, Alexandria Math. Maybe I want to do the fast power, and in particular, I want the function fast power, right? I'm gonna use this one, and let's give it a try. So let's create a new test scenario, test function, and this is test advanced math. So I'm gonna have let's define a variable called a u32. Let's say that it's 4, and I'm gonna do an assertion saying if I call the function fast power, so basically a to the power of 2, I should be able to get 16, right? This is how I use in the function that I brought to scope here at the top, the fast power. Give it a try. So it is working. It brought the dependency. You can use it. If I want to use the square root, for example, I can bring another one of those functions. Use Alexandria Math. Maybe that was square. What's the name? Oh, fast root. And the function is called fast square root. So let's call it here, cert past square root. And this one is expecting to be passed, what is it? A. Let me see my notes. Doesn't tell me exactly. It needs one more argument. I think it's one. I think the issue that this expect to be a different type. Yeah, it expects the type to be unsigned integer 128, and I'm passing u32. So to convert between types, you can use a function that's called into. And this should work. So this should be 2. Now the square root of 4 is 2. Let's give it a try, scrap test. And something's failing because I forgot to put the semicolon at the end. So let's try again. Now it's passing. So now you know basically that you can do some basic operations with unsigned integers and with signed integers, and that they have either overflow protection so it doesn't go over, and underflow protection so it doesn't go under. And if you want to do some advanced math, you can actually bring a dependency into your project from scarps.xyz, and by defining here in the dependencies, and then you will have to bring it into scope using the keyword use, as I use here in the top. Let's see how much time do we have. Okay, we have a couple more minutes, so let's keep going. Next topic. So Tung, are there any questions somewhere? Or?
No, all good for now.
Okay, all good. Okay, so I talk about integers. Let's talk about fields. So this is a default type of Cairo. Fields.cairo. So I'm gonna define a new module, fields. And let me close some of this stuff to not get confused. All right, fields. And my notes. Good. Okay, I start with a new test suite, CFG, my unit test, module tests. All right, scenario number 1 that I want to show is implicit versus explicit types. So test implicit versus explicit. What I mean is that if you define a variable and you don't define the type, say a equals 5, the compiler is going to assume that the type is felt252. It's not unsigned integer or signed integer, felt. Now you can be explicit about it and just define the type yourself. And this works as well. So this is the default type of Cairo. And if I do an assertion, you see, just to verify that both are the same type, A should be equals to B. Okay, they should pass. All good. Let's do some basic arithmetic with fields so you can see some of the differences with signed integers. So function test field math. So if we find two variables, I'm gonna copy this A and B. Let's be explicit in both cases. Field. To say that one is like a 2, 4 and 2. Okay, simple numbers. So I can do obviously addition, do A plus B, and it should be equals to 6, and it should work. I can do also subtraction. I can do A minus B, and it should be 2. And I can do multiplication, A times B, it should be 8. So far so good. If we run the test, they all should pass. Right, they're passing, all good. Now this is where the issue comes, division. If I try to do an integer division, 8 divided by b equals 0, this doesn't work. It doesn't work. Trait has no implementation in context, core traits, blah, blah, blah. Division with fails works very different than for integers. So this is why it's complaining. Like this integer division only makes sense for integers. So you cannot do this with fails. In the same way, you cannot do this other operation, modulo, which is like the companion operation. Also complains, right? We were able to do this for integers, but not with fails. So this is reason number one why not to use fails. It doesn't support all the operations that you would expecting from a basic type. The other thing that happens with fails is the overflow protection. So let's do a function test overflow failed. So let's define a type. All right. So what is the maximum value you can store in a failed? So failed is a field element, and the reason it exists is just because it what powers basically the math of Starks to create this proof. It's all based on field elements, which means that all operations are basically moduled by a large prime number. And that large prime number is exactly this guy here. It's a very, very large prime number that to store it, you will require 252 bits. So that's why it's called failed 252. Meaning that if I try to go over this number, I should get overflow. The same way that with uint, if you try to go from 255 to 256, it should fail. So to test this, I'm gonna basically create a new variable. Let's call it let. Let's take that number, that large prime number, and divide by 10 to have something that we know is smaller. So let's basically take this number. I'm gonna remove one digit, the last digit. So instead of 3, just remove that. Okay. Then I'll try to multiply this by 100. So I know they're gonna try to it will go over the maximum value. Wow. So if we have overflow protection, this should panic, right? So it is passing. It is not panicking. And that is because in field elements, it is normal to overflow. It's part of how the math works, but it's not what you would expect in your code. So this could be very deceiving. So this, obviously, what we expect this is to panic, which is it's not doing. So this test should fail. So let's ignore this because this is not working because there's no overflow protection. What you want to take home is that use fails only if you really know what you're doing. But what you really know most of the time is unsigned integers or signed integers. So make sure that you use them. But be careful because failed is the default type. So if you don't define a type, it's just going to assume it's a failed, and you have these problems. What else? And just to bring the point home, let me. Well, I actually showed you the overflow protection before, but so let me show you. There's one reason to use fails in a right way, and that is called short strings. So let me create a new test scenario. Function test short strings, short string. And what I mean is that if I create a new variable, let's call it short string. Let's say this is a failed 252. Instead of giving just a number, I can give it a simple string like hello. And this is fine because what it's doing under the hood is taking this string as a set of ASCII characters or codes and turn it into the equivalent, like encoding in ASCII to put in a single felt, right? So let's say let's have something very small like A that we know the ASCII. So I can do an assertion and say, well, so this short string is actually 97 because if you go to the ASCII table, the ASCII for A is 97 in decimal. In hexadecimal will be different. So if we test this, it's actually passing, right? So this is just to show you that this conversion, the only thing they're doing is encoding ASCII into a single felt. The limitation though is that because a felt only has 252 bits maximum, there's a limit to how many characters you can put in a felt, in a short string, to 31 characters. So if I keep going, some point say, hey, this is not gonna fit in a single felt. So that is a limitation to try to use strings with fails. This was it's called short string for that reason. Maximum 31 characters, but it's actually a failed under the hood. Now, if you actually want to have something that is not limited by 31 characters, there's something called a byte array, test byte array, that has a different syntax, and the type is actually byte array. Byte array. So now you can say this can be of any limit. And I can keep adding, and it's fine. There's no limit to how many characters, but notice that you have to use double quotes. Double quotes with byte array, you don't have any limit, and single quote is actually a short string, which is actually a felt. So let me bring this short here. Just to prove that it's actually working, let's do an assertion. Let's say now you can see what's the length of this string. And in this case, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Should be 24 characters. Let's give it a try. And it passes, right? So you have now new methods because this is a byte array. So that's the point I want to make about fields. It is the default type, but because of the way field elements work, the math, you cannot do divisions or integer division or modulo, and it doesn't have overflow protection just because that's how the math of field elements work. And you can use them as a short string. Just keep in mind there's just an encoding of ASCII, but you have a limit of 31 characters, in this case using single quotes. But if you want to actually have something to an array, but you don't have any limit, you can use byte array and then double quote. However, you cannot use UTF-8 characters, so there's no concept of like accentuations, right? This is not supported yet by language. Only plain ASCII characters are supported at this point. How much time? 12:47. Okay, I think we have time for a couple more things to do.
Hey, David, we have a question in Zoom.
Yeah.
So
What's the
Suraj
question?
is asking for each test, there is a gas usage. Can you clarify about that?
The gas usage. Oh,
Yes.
right, this one here. Let's say that in the case of vanilla Cairo, this is not as relevant because its gas is used on a Starknet. So actually, it makes sense. Let's disable that for this particular project. And to disable gas, to check my notes, there's a property called Cairo. Enable gas false. Gas only makes sense for a Starknet because that's how we actually measure how much computation you're using from the network. And based on that, that's how much you pay in fees for the transaction. So now if I run a script test, gas should be gone. That's a very good observation. Thank you. Yeah. Any other question?
All good.
All good. Okay. Well, I actually have a few minutes only. So maybe with the time that I have left, let me show you where to go next to learn more because I'm only scratching the surface of the language. It's important that you know the language very well before you start writing smart contracts. So first place you could go to learn more about Cairo is the Cairo, no, not Cairo code, Cairo book. Okay. And this is the link, Starknet.io, Cairo book. And that's all you need to know really to learn all about Cairo, all the details. Very good read. We also did a 2-hour, actually a 3-hour session, very similar to what we did today, but I cover way more ground about Cairo, and that is on YouTube. And I think we need to put it somewhere in the chat because I know this is not yet public.
Yeah, it's in the
Uh,
chat.
it's in the chat. Yeah, we have a recording. It's like a 3-hour recording, basically what I'm doing today, but covering a lot of topics. And if I show you my screen, this is the full version of the repository. So I cover casting, so you can how you switch from one type to the other. I cover arrays, in this case also how to do iterations, the concept of snapshots and references, which is going to be very important when we get to smart contracts. You're going to see that a lot. You're going to see structs to define custom types, and then traits to define behavior for the custom types. And then you have things like generics as well to create more flexible types as well. So make sure to check the video. I cover all those things there. And what else I want to show? Um, I think in the list that I shared with you,
Sparklings.
Sutton, Starlings, yes. This is a great way to learn more about Cairo in a very dynamic way because it's a bunch of exercises you can do in your browser, and it's a bunch of challenges. It's a great way to learn, and you can actually when you complete the whole thing, you get to be like a Starlings graduate, which we actually use it as a graduation criteria for a course that we call Starknet Basecamp that we're actually about to close this week as well. That's it. That's all
And
that I
also
have planned.
startup.
Yeah, Starkup is what I showed at the very beginning to install
Ah,
all the
okay. So then we
dependencies.
are all covered.
So you have it here, right? This is what I used to install Scarp and SDF and all the things that you will need not only for just Cairo, but also for Cairo smart contracts. So the workshop tomorrow is to take this knowledge and now actually build a smart contract and and do some testing as well for smart contracts using Starknet Foundry. Because today we use the default test runner of Cairo, which is called Cairo Test. It's just smaller, simpler. That's it. Any question?
All good for now.
All good. All right. Well, if you have any question after, I'm gonna be also in the chat for the Telegram. So good luck with the hackathon, and yeah, I'll see you tomorrow for the workshop number 2. Oh, there's a question. Source asking, why do we use felt 252? That's a good question. When would you use felt? The only reason I really think is maybe short strings, maybe, because it's a simple type. Sometimes, for example, when you want to emit an event, and this is part of the smart contract, when you want to emit an event and want to put some value in the event, usually a fail 252 is more readable because it's a single value. When you have something like a byte array, you have to serialize this before it can be displayed. And when you serialize, you turn a complex type into an array of fields. So that's one thing to keep in mind. But with the right tooling, every time can be deserialized as well. My suggestion is never use felt unless you really know what you're doing. There may be some optimization techniques, but this is way more advanced. You should always stick to unsigned integers or signed integers depending on what you want to do. Any other question? You could just use integers. Yes, you can just use integers, and that is my recommendation. And usually for smart contracts, the type that you use for the most part is U252, like U256, which is very similar to what you have in Solidity. So it makes sense to stick to that. Just to make sure is that when you have that type U56 and you pass and you pass it like I'd say a constructor is expecting that type to be passed, you have to serialize it. Usually the tools take care of that, but just so you know, at the end, what Cairo really understands or Starknet is fails. It's just we serialize and deserialize for failed uh, to get to U56, U256. Any more question? Mm, no more questions apparently. Okay, that's all for me. Thank you very much. I'll see you tomorrow for workshop number 2.
Bye.